So we're still in Chapter 1, Equations and Inequalities, and now we're going to look at Section 1.2, Quadratic Equations. So the first thing that we're going to do is solve a quadratic equation by factoring. This should feel very familiar. The second one is to solve a quadratic equation by completing the square. This is actually a very important skill that keeps coming in handy. Solve a quadratic equation using the quadratic formula. Hopefully that's also familiar, and this will be a lot of review. And then solve problems that can be modeled using quadratic equations. So you can see how the progression is similar to the last section that we did, where first we just look at doing the algebra work and then we say, well, what good is this? What can you use it for? Each section in the textbook has a little part at the beginning that says preparing for this section. So it directs you to exactly where you need to go if you need to review any of these pre-skills that you'll need to be successful in this section. So make sure and do that if those don't sound familiar or if you need a little brush up. So as usual, we start with a definition so that we all know what we're talking about. And a quadratic equation is an equation equivalent to one of the form. So you can see why we talked about form yesterday. It's going to keep coming up. Of the form ax squared plus bx plus c equals 0. A, B, and C are real numbers for us here in this class. And we need A to not be 0. If A is 0, then you would be back to a linear equation. So we need to have the A not 0. B can be 0, C can be 0, that's fine. So again, in any given problem, the x is always the variable. It's varying, taking on different values. And the A and the B and the C are called constants, and in a given problem, they would be numbers, different in different problems. So let's look at objective 1, where we're going to solve a quadratic equation by factoring. So we're going to solve the equation x squared minus 4x equals 0. And this one should be very straightforward. We'll do it really quickly in class together tomorrow, and the next example also. And remembering that I'm always choosing examples very thoughtfully to illustrate a particular point. Okay, so now we're going to talk about the square root method. So we need this important little factoid. If x squared equals p, and p is greater than or equal to 0, so that's important. Think about why. Why does p need to be greater than or equal to 0? Oh, because we're going to be talking about square roots, and we're still in real numbers. We'll make a big transition later to complex numbers, and that will change everything. So if x squared equals p, and p is greater than or equal to 0, then either x equals the square root of p, or x equals the opposite of the square root of p. Remembering that this symbol means the positive square root. Or it's also called the principal square root. So if we write this, this is the same thing as writing the number 7. So if you want to say -7, you have to put the negative on the outside of the square root. So using the square root method, we'll solve this equation together in class and go on to objective 2, which is solving quadratic equations by the square root method, by completing the square, sorry. I think I could remember from one moment to the next. By completing the square. Okay, so the directions are going to say solve by completing the square. And if this is on a test, it's going to say no other method will receive credit. So even if you could solve it by factoring or the quadratic formula, you really need to learn how to complete the square. So I'm going to require it. Okay, so for this one, it's a little complicated because it has the 2 in the front. You cannot do complete the square with a coefficient on the x squared, so you have to take care of that. So the first thing I do is put the constant on the opposite side of the equals. So now I have 2x squared plus 6x equals 5. Then I divide both sides by 2 so that I don't have a coefficient on the x squared. So now I have x squared plus 3x equals 5/2. Now on the right-hand side, you're trying to complete the square. So you want x squared plus 3x plus c to be some perfect square binomial. So you have to figure out what goes in here by figuring out what goes here. So the way you do it is you look at the b, the coefficient of the x, it's 3. You divide it in half and you square that number, and that's how you get the c that goes here. So I have x squared plus 3x plus 9/4. Well, then that's going to equal x plus, this is always going to be b over 2. So x plus 3/2 quantity squared. So FOIL that out and make sure it really works. So if I add 9/4 to both sides here, I haven't changed the equation. I'm using the additive property of equality. And then this is the perfect square binomial, x plus 3/2 quantity squared. And now I need to turn this into 10/4 plus 9/4. So that's going to be 19/4. So then we're going to finish solving by saying x plus 3/2 must equal plus or minus the square root of 19 over 4. And you should never leave a 4 inside a square root. So you should say x plus 3/2 is plus or minus square root of 19 over 2. So you need to completely solve it by saying x equals negative 3/2 plus or minus the square root of 19 over 2. Okay, so you may need to do some practice on those if they're tough for you. They're challenging for a lot of students. Okay, so objective 3 is going to be solving quadratic equations using the quadratic formula. And the quadratic formula is actually a theorem. So it has 2 parts to it. It has an if part and a then part. And if you don't have the if part, you don't get the then part. So if ax squared plus bx plus c equals 0, then x equals the opposite of b, plus or minus the square root of b squared minus 4ac, all over 2a. So what does that quantity b squared minus 4ac tell you about the solutions? Well, that quantity b squared minus 4ac actually has a special name. It's called the discriminant. And if b squared minus 4ac equals 0, then you can see that you just get x equals negative b over 2a, and there is only one solution. And then you should kind of whack yourself on the forehead and go, oh, I could have solved that a lot easier. So if b squared minus 4ac is greater than 0, then we have 2 solutions. And they're real solutions. They might be irrational, like that previous one we did with square root of 19, but they're real. And if b squared minus 4ac is less than 0, then we have 2 complex solutions, which we'll talk about later in a later chapter. So use the quadratic formula to find the real solutions, if any, of the equation. So complex numbers will come later. If I ask you for real solutions and there are only complex solutions, you should say there are no real solutions. So we'll do this problem together in class. Notice it's in the form ax squared plus bx plus c equals 0. That's necessary before you begin to identify a, b, and c. Okay, and then we'll do objective 4 together in class, looking at the modeling problem. And that's it.